Section 4.3 is division of polynomials. The first example is going to have us divide a polynomial by a monomial. We talked last time about what a polynomial function looks like, right? It has integer powers that are positive, okay, and the domain is all real numbers. So here in example 1, we're asked to divide 4x to the fourth plus 8x squared minus 5x by 4x squared. When we set this problem up, we write down the polynomial 4x to the fourth plus 8x squared minus 5x, and then we're dividing it by the monomial 4x squared. If you have a single term in the denominator of a fraction, you can distribute that term across the fraction. Remember, if you have a fraction a over b plus c over b, if you have a common denominator, you can add the numerators together. Taking this side and writing it in reverse is what we're doing here. We're distributing that denominator across each one of the terms. So that allows me to write this division problem as 4x to the fourth over 4x squared plus 8x squared over 4x squared minus 5x over 4x squared. Now it's just a matter of reducing these fractions. 4 goes into 4, x squared goes into x to the fourth 2 times, and that's going to give me x squared. 4 goes into 8 2 times, and x squares divide each other out, so this is x squared plus 2 minus, and here this x will cancel with one of these x's and leaving me 5 over 4x. And that's how we would simplify that division. In example 2, we're asked to divide a polynomial not by a monomial now, but by a binomial. Before we do this, I want to remind you how we do division just with numbers. So if I had the number 175 and I asked you to divide this by 3, we would take 3 and divide it into 17 and see that it goes how many times? So 17 divided by 3 is 5 with the remainder of 2. So we would say that this is equal to 5, and then we would multiply 5 times 3 is 15. Well, when we do our long division with the polynomials, we do the same thing. We divide this first term by this first term, and we write down whatever we get right here. And then we multiply what's on top by what's out front. And then what do? We subtract. And then we would say that that's 2, and then we would bring down the next term, and then we would say 3 goes into 25 how many times? 8. And 3 times 8 is 24. And then we would subtract, and our remainder is 1. And that 1 we can write as 1/3. We'd take our remainder and put it over our divisor. So 175 divided by 3 would be 58 1/3. And we could check our division by multiplying our divisor by our quotient plus the remainder. And when we do this on our calculator, what's 3 times 58? And 174 plus 1 is 175. So what we see is the divisor, that's what this number is, goes into the dividend, and the 1 here would be our remainder, and the 58 and 1/3 is what we call our quotient. Well, actually just the 58 would be the quotient, and then we take our remainder and put it over the divisor. To check division, you would take your divisor times the quotient plus the remainder equals the dividend. I want to explain how this works with numbers because we use the same process when we're dividing polynomials, and we use the same terminology. So in example 2, when I'm asked to divide this polynomial by x minus 2, what I'm dividing is my dividend. It goes underneath the division symbol here. So this is going to be 3x cubed minus 3x squared minus 2x minus 4. Then we put our quotient out front. So this is the quotient, this is the dividend. And the way that we divide a polynomial, I've got some scratch work I can do. Over here, I'm going to take the first term in my polynomial and divide it by the first term in the binomial that's out front. So I get 3x cubed divided by x is equal to 3x squared. That's what goes on top here. And then I multiply this by my divisor. And when I multiply a binomial times a monomial, I have to distribute. So when I do that, I get minus 3x cubed, because 3x squared times x is 3x cubed, minus 6x squared. What was our next step once we multiplied? We have to subtract. Well, subtracting is the same thing as changing the signs and adding. Subtracting is just changing the signs and adding. And what I typically do when I'm dividing polynomials is I will circle the signs once I know that I've subtracted or I've changed the signs. Now when I add, I get 3x cubed minus 3x cubed is going to zero out. Minus 3x squared plus 6x squared is 3x squared. And then I bring down that next term of negative 2x. So what I did here was I multiplied, then I subtracted. I just divide the first terms only. That's what the scratch work is over here. Then I multiplied what I got from my quotient by what's out front, and then I subtract, and then I bring down the next term. Now I'm going to have to divide 3x squared minus 2x by x minus 2. When I do that, I'm looking only at this first term. So I would say 3x squared divided by x is 3x, and that's what's going to go on top, the 3x. The question was, why is it squared on the top, but when I write it down here it's cubed? Because how I got this term was I distributed that 3x squared to the x minus 2. So if I have 3x squared times x minus 2, when I distribute it, that's what I got to put right here. So the 3x squared times x is 3x cubed, and the 3x squared times 2 is 6x squared. Is it always going to be positive? The answer is no. It's just a happy coincidence for this one that it is positive. And we'll see some more examples coming up where they're not going to be positive. So now I'm going to divide 3x squared by x, and when I do that I get 3x, so I put my 3x on top. Now I need to distribute again. I'm going to take this 3x here and I multiply it by the x minus 2, and that's what I'm going to put right here. So 3x times x is 3x squared, and then 3x times negative 2 is minus 6x. What's my next step going to be? So when I subtract, I'm changing my signs and I'm adding. That's going to give me 3x squared minus 3x squared is 0. Negative 2x plus 6x is 4x. And now I need to go through the process again after I bring down my negative 4. So I come over here to the side and I'm going to do 4x divided by x, just the first term divided by the first term. Whatever follows that first term, just let happen what's going to happen when you multiply. I take 4x divided by x, and that's going to give me 4, so I put a 4 up here on top. Now I multiply 4 times x minus 2, and that's what I'm going to put right here, and that's going to give me 4x minus 8. Now I change my signs and I add. The 4x's are going to cancel out. Negative 4 plus 8 is 4, and this 4 is my remainder. So my answer for this would be 3x squared plus 3x plus 4 plus 4 over x minus 2. The 4 is my remainder, this is my quotient, divisor, and dividend. If I were to check this answer, how would I check it? I would take this and multiply it by x minus 2, and I'm not going to take the time to do that. I would multiply my answer by x minus 2, and I have to get my dividend back. So this brings us to the division algorithm for polynomials. Let f of x and d of x be two polynomials with degree of d of x greater than 0 and less than the degree of f of x. There exists unique polynomials q of x and r of x such that f of x is equal to d of x times q of x plus r of x. F of x is your dividend. It's the polynomial that you're dividing. This d of x is your divisor. It's what you're dividing by. The power on the divisor has to be less than the power on the dividend. And then what you do is you multiply the divisor times the quotient plus the remainder, and that's what our dividend is. I explained all of that with numbers up here. I basically gave you our division algorithm, but I did it with numbers. If it works with numbers, it'll work with letters. Algebra shouldn't be a mystery. If you're good with arithmetic, you just apply the arithmetic processes, because the letters that are in the problem just take the place of a number. So if it works with numbers, it has to work with letters. Now another type of division that I think is easier and you can use as long as you're dividing by a linear factor, is something called synthetic division. Have y'all heard of synthetic division before? Synthetic division is just a division process where you work only with the numbers and you take the letters out of play. That's why I think it's easier. So a shortcut is called synthetic division, and it can be used to divide x minus k into a polynomial. You have to have a linear factor in order to do synthetic division. The steps you're going to go through: you're going to write k to the left and the coefficients of f of x to the right, just the numbers. If any power is missing in f of x, any power of x, we're going to put in a 0 for that missing power of x. Then we copy the leading coefficient into the third row and multiply it by k. Write the results below the next coefficient in the second row, and then add the numbers in the second column and place the result in the third row. This sounds more complicated than what it is when we go through it in practice, so I'm not going to read these steps to you. We're just going to go through and do this. Now, the thing to keep in mind is when you're doing synthetic division, x minus k is the factor. The number that we put out front, though, would be k. In this case, x plus 1 we could rewrite as x minus negative 1. So the number that I'm putting out front for my synthetic division is going to be negative 1, and we just kind of box it off like that. Then we write the coefficients of our polynomial out beside that number that we're going to be dividing by. This is a third degree polynomial, so my coefficient for x cubed is 2, the coefficient for x squared is negative 4, the coefficient for x is missing, so I'm going to put a 0 because I can add a 0x there, and then I need the coefficient for my constant term. The way this works is you bring down that first number, so that's going to give us 2. Then we multiply. Negative 1 times 2 is negative 2. We put that product right here. So from here to here, I'm multiplying negative 1 times 2. Then I add these numbers to get negative 6. Then negative 1 times negative 6 is 6. I multiplied negative 6 times 1, and then I add 0 and 6 to get 6, and then negative 1 times 6 is negative 6, and I multiplied negative 1 times 6 to get that negative 6, and then I add to get negative 7. Do you see what I just did there? I add the numbers and going down the columns, but I'm multiplying negative 1 times the number here and putting the product here. Negative 1 times the number here, the product goes here. Negative 1 times the number here, the product goes there. Now when you do synthetic division, because you're dividing an x cubed by an x, the numbers down here are the coefficients for an x squared. So what I would have here is 2x squared minus 6x plus 6, and my remainder is 7, so I would write 7 divided by x plus 1, my divisor, and this would be my final answer. The number that's right here is the remainder. If you divide a cubic function by a linear function, the result is going to be a quadratic function. The constants that appear right here are the coefficients of a second degree polynomial. And then your remainder you just put over the divisor. When you do synthetic division, if you're given a factor to divide by, use the opposite sign. If you know what a 0 is or a root is, you would just use the number for the root. If I was dividing by x minus 1, I would put a plus 1 right here. So you can think of it like this. I'm changing the sign on this number. Well, that takes care of my subtraction when I change the sign and add. The question was, where did this 0 come from? Well, this polynomial I could rewrite as 2x cubed plus 4x squared plus 0x's minus 1, because you have to have a number for every descending power of x. Because I didn't have an x term, if I multiply x times 0, I get 0, so I just put that 0 there to fill in the gap where the power of x was. When you do synthetic division, you need to have a number for every power of x. So if this would have been a 5th degree polynomial, I would have needed a number for x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and a constant. You could have multiple zeros, yes. It's going to be 1 degree less. on the power of x. These are the constants that go in front of the variables, starting with the highest power being 1 less than what our original problem was, our original polynomial was. By the way, these are some of the things that I say but don't write down that you should probably be writing down in your notes, because they're questions that you asked, and then what I say makes it make sense to you. So even if I don't write it down in your notes, you should be writing those things down. That's just good note taking. And the last thing we're going to look at in this section is something called the remainder theorem. The remainder theorem says that if a polynomial f of x is divided by x minus k, then the remainder is going to be f of k. Thus, f of k is equal to the remainder in the synthetic division. Alright, so what I would like you to do here is to use the remainder theorem to check the remainder that we got from example 3. That was the example that we just did, this problem up here. That was the instructions up here. We got a remainder of -7. I want to check and see if this remainder theorem works. So to check it, what I would do is I would let f of x be equal to 2x cubed minus 4x squared minus 1. And to find the remainder when I divide by x plus 1, remember I could rewrite that as x minus a -1, I would find f of -1. Your factor should always be in the form x minus k. That minus is part of it. So if this is a plus, I need to change the sign. So 2 times -1 cubed minus 4 times -1 squared minus 1 is f of -1. What happens when you cube a negative? It's still negative, so this is going to be equal to -2. What happens when I square a negative? So this is -4 times 1 is -4, and then minus 1. -2 minus 4 is -4 minus 1 is -7. And that's the same thing that we got in the problem above. We had a remainder of -7. If you're asked a homework problem or a test question where I just give you a polynomial and say, what's the remainder if you divide by x minus 4? All you got to do is find f of 4, and that'll tell you what the remainder is. In the next section, we're going to see how we can use this, how it comes in handy. Yes, this method up here is synthetic division. Yeah, the synthetic division would work on this one as well. It's got to have an x minus a number in order to do the synthetic division. So that wraps up section 4.3.